Hi functions. Okay, so I'm trying a different strategy. I'm putting my computer in a different spot so you'll see the top of my Elmo. It's not perfect, but at least it's a little bit better, and I'm looking towards the camera instead of always, off to the side. So anyway, I would like you all to take this graph down and plot these points, answer this question, and we will work our way through this. So go ahead and hit pause, and I'm going to hit pause so I can switch the tape. Okay, so I went ahead and I plotted them, and all of them are in pink. So this is 3, -1, we have 5, 3, and so forth. So all of the ones in pink correlate to this one right here. Yeah, if I draw a straight line through any of these, any straight vertical line, it's going to pass the vertical line test. So I am good there. So yes, it is a function, and it passes the vertical line test. Then I went ahead and I switched the x and the y values. So I did that in purple, and then I plotted them in purple. So I did that, and if I draw a straight vertical line through any of the purple ones, then yes, it does pass the vertical line test. Now, I'm not looking at the pink and the purple, because obviously if I was looking at that right here, would not pass the vertical line test. I'm just looking at individually the purple. So you see this black line, and that black line is it is called y equals x. So it's got a slope of 1 to 1, and it goes right through the origin. My y-intercept is 0. So if we think about that, if we look at this pink dot, everywhere it reflects to this purple dot, and this pink one reflects to this purple one. And so if you guys remember from geometry when we're talking about reflections, this is going to be the same distance from this line as this one. And this is going to be the same distance from this line as this one. So that is the reflection. Or if you drew a mirror, you would see a reflection of that. So in inverse, so go ahead and put these notes in your notebook. An inverse of a one-to-one function means that each x value has its own individual y value. So we have talked about f of x equals x squared, that parent graph. Well, if we go like this and we graph it, and if I put in -1 and I put in +1, it's still a function because it passes that vertical line test, but it's not a one-to-one function because if you draw a horizontal line, it's going to hit it twice. So a one-to-one function always passes the horizontal line test. So an example of one that does would be f of x equals x cubed. Well, that graph looks like this. Okay, so this does pass the horizontal line test, but also the values at -1 and 1 are different. So if I were to plug in, if I were to do 1 and -1, I get 1 and I get 1. If I were to do the same thing here, and +1 here, I would get 1 here and -1 here. Two different answers. So two different answers means it's a one-to-one. So get that in your notes, hit pause if you need to. Okay, so this is a fancy definition. So the inverse of a one-to-one function is written this way. So the notation for a one-to-one inverse is like this. That's what that says right there. And that means that the set of all the order pairs are that you can switch the x's and the y's. So that's what that says there. And then that means that the domain and range also switch. So I'm going to give you an example. I don't know if this would actually work, but I want to show you how it would work. So if f of x's domain, let's say the domain of f of x is -∞ to infinity, and the range is 3, we'll say -3 to 7, okay? So then the f of -1 The inverse of that, the domain, would be whatever the range was, so -3, 7, and the range would be negative infinity to infinity. So that's what it would look like. Again, I don't know if this would work. I'd have to graph it, but I just wanted to show you how it switches. So it makes sense. If you switch the x and the y, then you switch the domain and range, especially since domain relates to x and range relates to y. So make sure you get all of this in your notes and hit pause.